Ladies and gentlemen, welcome back. We will now proceed to the first plenary on cybersecurity. In this session, we're going to focus on the impact and challenges of deploying new and important technologies and solutions. The moderator for this session is Mr. Jia-Rong Lo, Vice President of Global Stakeholder Engagement and Managing Director, Asia Pacific at ICANN. Please welcome the moderator for the session, Mr. Lo. Mr. Lo, the floor is yours.
Thank you, and good morning, everybody. I hope you can hear me well.
Yes, we can hear you very clearly.
Yes. Thank you. All right, so let's begin. My name is Jia-Rong, and I'm based in Singapore. I have to look after the ICANN Asia Pacific office. And I'm very grateful for everyone for taking the time, and also for our panelists. Today, we are going to have an interesting discussion, dialogue style instead of presentation style. So hopefully that will be more engaging for all of us. First of all, again, a big thank you to TWNIC for partnering us, the ICANN Asia Pacific office, that we're able to host this event, albeit in a hybrid format, even though in 2019, when we first started, it was a face-to-face structure. Hopefully, we will be able to be in Taiwan together with you again, face-to-face. And I really love Taiwan and the food, especially. Yesterday, we had one session that talked about using technology for smart kitchens and delivery, and that made everybody very hungry. And I'm also mindful that today's session, we are sitting right before lunch. So let's try to make it a bit more engaging, and hopefully we will end on time so everybody can go for lunch. With those more important matters settled, let me introduce our speakers. I'll share my screen. So today's session is on the Cybersecurity Plenary 1, and the theme is on adopting important technologies. So what are these important technologies? We'll go to that in a bit. And first of all, I'll introduce our speakers. We have Adil Akpogan, our Vice President for Technical Engagement in ICANN. He's basically the main person leading all our technical engagements, and when it comes to any technical issues, Adil is fronting ICANN on those issues. So we got our best expert here with us at this session. So very grateful to have you with us, Adil. Then our next speaker is Jamie Gillespie. He's the Internet Security Specialist from Rpki. Jamie's been going around 56 economies in the Asia-Pacific region, doing security training, outreach, working with certs in the developments, with law enforcement agencies, network operators. So again, we've got a very good expert who knows the issues very well, and I hope that we can really learn from him in depth here. And our next two speakers are on site, and we have Kenny. So Kenny needs no introduction. He's the member of the board and CEO of TWNIC, with a very, very long and well-established CV. So there's no real introduction we need, but we hope to learn from him regarding his experience here. And our fourth speaker is Yan Jie. We'll call him Jack. Yeah. He's the Senior Engineer Data Communications Business Group from Chunghwa Telecom. He's been with Chunghwa Telecom since 2009 and is a member of TWNOG. He's the Senior IP Operations Engineer responsible for the HiNet International Backbone Network and TWIX. So we've got a very good panel of specialists, of experts. Hopefully we can have a very good discussion. And for the participants, I would like to encourage you as well. We will have portions for discussion and Q&A. So I would like to invite you to join us in the discussion. And I won't get to see the hands in the room. So Kenny, I may have to trouble you to help me a little bit when you see any hands in the room who want to ask questions.
Yeah, no problem.
Thank you. All right, so let's get started. So when it comes to the topic of important technologies, within the unique identifier space, for the ICANN community, for the Rpki community, even when it comes to the IETF, for example, the community has been pushing for the adoption of some important technologies such as DNSSEC, such as IPv6, Rpki, and ROA. I know some of the participants, you will not know what these technologies are. The terms may not be familiar for you. But to level the playing field, let's invite Adil and Jamie to talk a bit about what these technologies are first, so that when we have the discussion later, everyone is on the same page about what they are. So can we have Adil first talk about maybe DNSSEC more broadly, just to get people to understand what these are. Then we'll go to a next question about who should care, who should be doing it, but focus more on defining what these technologies are in the first place. So Adil, over to you first.
Thank you very much, Jaron, and good morning to everyone and on site. Always happy to be with you. So yeah, your question is very interesting. Well, what is DNSSEC and what is DNS security in general? I have a set of 2 or 3 slides. I will try to share them again. I had an issue yesterday doing this, a very weird issue. Let's see if today is my lucky day. So I'm going to do this. I'm going to start by dissociating, when we talk about security of the DNS from the DNSSEC in general. I know that usually when we talk about security, we jump into the DNSSEC first because it is one of the hanging fruit protocol. But the security of the DNS, to set the scene, is something a little bit complex, because the DNS originally was a simple protocol that was designed to map name to IP addresses, but over the time it started evolving, and that simplicity has also intrinsically implied some security weakness. So over the time, security has been added. Other aspects of the ecosystem has evolved as well. So when we talk about the DNS security in general, we look at the 4 key elements of the DNS, the protocol itself, which has been tightened and hardening by adding security measure, and DNSSEC is one of them. And to talk about that, we have the namespace as well, which define all the name in the DNS, and that also has to be protected. The service, which is the way we as user in general from our device, we access to that mapping through the star, the recursive, and the authoritative servers, and then the provisioning part, which is the part that interests ICANN from the policy perspective, which is where you can buy and register your domain name. So all those 4 pieces of the DNS ecosystem has to be taken into consideration when we talk about securing the DNS. This small graph gives an idea, a little bit, very high-level idea of what we are talking about, taking the service side and looking at the interaction between the stub resolver, which is usually the device we are using, either our laptop or mobile phone. Its interaction with the recursive server is a point of contention and a point of possible security risk and need to be secure. The recursive server itself holds some information, and that information as well is prone to security attack. It's prone to different kind of things like cache poisoning and so on. And when we go through this chain of interaction in the way the DNS work, we will see that at each point we have a risk that needs to be mitigated. One other aspect of this, which is the provisioning that I talked about in my previous slide, is another element of risk in this whole ecosystem, because users interact with registrar to get their domain name, and they do that through interface. They do that through authentication and different other methods to access the database, to access information related to their registration. And at that level as well, we'll find again, general IT security, general risk associated to those user authentication, associated with the interaction between the registrar, that is the kind of the reseller, and the registry, that is the main registry of the TLD. The interaction between both also follow a specific protocol that may be also prone to risk. So all of that need to be taken into consideration. And that's where we talk about, DNS security, DNS ecosystem security in general, where the DNSSEC will play a very specific role. So if we take that graph and plug in some security measure, we will see clearly, as I mentioned, that DNSSEC is one of them, and only address the interaction between the recursive server and the authoritative server. And what does the DNS will do here? We solve one aspect of the problem that we have at that level, which is the authentication of the information provided by the authoritative server. In a simple way, when you want to access a domain name online, you send your request to your recursive server. That has the responsibility now to do the recursion. That means go to the authoritative server, find the information of the top level domain, and then move down the tree. When doing that, there is an exchange between your recursive server, which is hosted either by your ISP or within your IT infrastructure, and the authoritative server that provides the answer to the question. That answer by default is plain text. It doesn't have any authenticity or authentication, which means that anyone in the middle can either hijack the information, change it, and send it to you. You won't know if the information you have received is coming from the right authoritative server or is accurate. So what the DNSSEC is coming to solve is to add a signature, a cryptographic signature that will come with your response. When you receive the response, you can then check the signature and make sure that the signature matches the information that you receive, but also ascertain that the server that sends you the information has the right and has the authority, effective authority, to send you the information that you have requested. So it is a way of adding authentication to the information, but it doesn't encrypt the information itself. It doesn't protect the content of that information. The analogy is a form. When you sign a form, you fill a form, a paper form, you fill it, you add information. At the end of the form, usually you have somewhere where you need to sign. So you sign that form that you have filled. There are information on the form. Anyone that takes the form can read the information, but your signature just says that this form has been filled by this person, and that person is saying that the information he has provided are accurate, but the information is still visible, unless you put that form in an envelope or you encrypt it or you change the information. So basically, the DNSSEC is solving one of the problems of the ecosystem by adding authentication to the exchange of information between your recursive server and the authoritative server that provide or that has the actual answer to any question that you ask. So it is a protocol, an extension of the DNS protocol that we promote a lot. Because it is one of the first security extension that was added to the DNS, and ICANN has a role to play in that because of its role in the root zone management. Assigned is the root, which allow everybody else to actually validate information, and we promote that because we think it is an important step in providing a secure environment for the DNS to operate. So I will stop there, and I hope I have been articulated clear enough to explain where exactly the DNS sec come into the picture here, and over the discussion, I guess we will come back and dig in a little bit more. Thank you.
Thank you, Adil. Very clear. So the key takeaway here is, for users, when you are searching for when you type a domain name, there's a lot of things going on behind in the background, and there's a lot of communication going on. So the communication that happens has multiple risk points. And amongst others, one of the areas that would help to mitigate this risk of people intercepting what you're looking for is DNSSEC. Thank you so much, Adil. We'll come back to some of the discussion in a bit, but let's hand over to Jamie, get everyone level the playing field, talk about some of the definitions of the technologies as well. Jamie, over to you, please.
Yes, thank you very much for the introduction, and thank you for having me speaking at this session today. It's wonderful to, even though I can't be there in person, I wish that I could, but at least I can participate virtually. So I have some slides here to show to help go through. Just make sure these are coming up okay. So the first one that we're going to be looking at is IPv6. Now, this is, some introductory information, making sure that everybody is having the basic understanding for the more advanced discussion later on. But starting with IPv4, this was the original addressing, numerical addressing for the internet, created from when the internet first started. IPv4 addresses are 32 binary digits or bits long, so 2 to the power of 32 gives us an upper limit of just over 4 billion IPv4 addresses. Now, a lot of these addresses are large blocks that have been put off and are held for private use, the 10 dot addresses and the 192.168 addresses. So these addresses, it's actually a lot less than the 4 billion. Now, since 1980, these addresses have been known that they will be exhausted or will run out and won't have any new ones available. So this is where IPv6 was created. Now, IPv6 has been around for many years now, but has only really been pushed for adoption now that network operators have realized they can't get any more IPv4 addresses, or they have to pay money for them and buy them on a side market that they can't get them from their internet registries. Now, IPv6 in comparison is 128 bits long, so 2 to the power of 128. This ends up with a very long number here. The technical term is 340 undecillion, or 340 trillions of IPv6 addresses. And the little math equation here, if you wanted to think about it another way, that if there was 1 trillion people on Earth and each person was earning $1 trillion per second, 24 hours a day, 7 days a week, 365 days a year, it would still take more than 10 million years before everybody earned a total of 340 undecillion dollars, which is, an astronomically large number. I think some people refer to it as more IP addresses than there are grains of sand on every beach in the world. Now, for this, subnetting is still going to work the same for you. A small network, and I put small in quotes here because it's still quite large, but a small network would get a /64 subnet of v6 addressing. And as you see here, this is 18 quintillion addresses. And of course, the larger networks, your large internet providers can get a /48 or even more if they have a need for it. And a /48 gives 65,000 of these /64 subnets. So as you can see, there is a lot of addresses. Even if you take the most positive view of IoT and every device in your home having an internet address, there's still plenty of addresses for this use. Now, what does this mean when it comes to security for IPv6? So for every system on the internet, we'll have multiple IPv6 addresses. Some of these will be used for local connections, the self-identifying address of the system, as well as the more public IPv6 address. So the understanding of a system could be presented from different views with different IP addresses at the exact same time, and understanding how that's going to work for your local as well as your border security systems. There's going to be different IP address requirements, of course, for the security systems. A lot of legacy security systems were designed looking for a number, the dotted quad numerical addressing for IPv4. And some of them don't understand IPv6 addressing, although this, of course, has been gotten a lot better more recently. But if you've built systems internally, you have to look at the code that you wrote, the libraries that you were using for it, and making sure that those are updated and understanding the new addressing standards. And of course, when you have such large addressing, network scanning for vulnerabilities can be quite difficult. You know, when you're scanning a regular IPv4 network like a /24, you can go through the 255 or 256 addresses quite easily for a network scan. But when you're dealing with trillions and quadrillions of addresses, scanning even to look for addresses that are alive and active can be quite difficult. So it's not impossible. You know, there are ways of having good records of what addresses are being allocated and then tying your security systems in so that they know to scan only systems that have a registered IPv6 address. But it is something that makes things more difficult, and we have to think a little bit different in how we're going to be scanning devices. And of course, there are protocol-specific security configurations that are unique to IPv6. It's not just a different addressing standard, but the entire packet of IP for the addressing is different. There's different prefixes, different headers on there that have to be looked at, and there's different ways of abusing those systems. A lot of those ways for abuse can lead to denial of service attacks. So you have to make sure that when you are deploying that you understand some of the differences that go beyond the addressing differences and making sure that you're protecting your systems for this new addressing standard. Now, some of the problems that can come when going and looking to deploy IPv6 is when you dual stack, or when you're running a computer and many systems and network with both IPv4 and IPv6 addresses at the same time, you have to make sure that your security systems are ready for the new addressing before it gets rolled out, even in a dual stack configuration. What we've seen for some security incidents is that IPv6 gets enabled for networks and for devices before the firewall is configured. So you may have very strict firewall rules based on your IPv4 addresses, and then suddenly IPv6 is enabled with no firewall rules at all. So all you have to do is move a little bit to the left, and you have a clear path from an attacker's point of view to access all of the networks, both inbound and outbound. And of course, we have to make sure that our people, processes, and technology are updated for understanding and handling IPv6. And not just the people, processes, and technology, but we have to look across the different phases of a security timeline. We have to make sure that we have the systems in place to protect our networks and systems from attacks before they happen, that we update and understand how to detect the attacks as they're happening in a new addressing and new protocol standard, and also looking at our incident response plans and programs to make sure that we know how to respond when there is difficulties that were mentioned above, such as different IP addresses that exist on the same system and how to correlate that information together. So that's on the IPv6 side of things. The next one looking at the other important technology is Rpki. Now, Rpki is very similar to other PKI systems. Here we're looking at a hierarchy of trust. Now, a very familiar PKI system that most people should be aware of is for SSL or TLS certificates. When you're visiting a secure website, that is using a PKI system with a hierarchy of trust, with your root certificates at the top issuing intermediate and then end certificates down to the smaller organizations or the individual websites. So here for Rpki or resource PKI, we have the regional registries, of which APNIC is the one highlighted in the middle, acting as the trust anchor or that root certificate authority for it. We do have in the Asia Pacific region some national internet registries that sit under APNIC, as well as you can see to the right side, APNIC issuing certificates to the end entity, or EE. This is the end network operator. So Rpki is a hierarchy of trust. Now we're going to see how this actually comes in and gets used. So here we have a standard network flow. You can imagine you running a network, the one on the left-hand side listed there, and you can see that there's an advertisement for a network address for a prefix from 178.1 on the right-hand side. And it comes across, it traverses a few networks to reach your network. And this is the regular way of BGP propagation. Now, what we have here is we have a malicious network operator. So this is somebody who is advertising the exact same addressing space, but you can see that they are one hop closer to you than the real network operator of that address. And because this is a shortest path, for a lot of networks, they will listen to that one as being a more reliable or a better route to that address. So this is how a lot of hijacking of addresses happens. Another common way for it is to advertise a more specific prefix or a smaller subnet for the routing, and more specific prefixes usually are given priority as well. So another way that a malicious person can hijack some address ranges. Now, when we build this in with Rpki, what we end up doing is we have the Rpki repository on the left-hand side, and in here, network operators create a ROA, or a Route Origin Authorization. This is basically a signed certificate from the Rpki system that says that they are the allocated operator for a specific IP address prefix, and that it is being routed using their AS number or ASN. These ROAs, or Route Origin Authorizations, are kept in the repository and then put down to a central validator point. Now, your individual networks can then synchronize and pull information from the validator in order to validate the routing information as it's brought in via BGP. So as you can see on the right-hand side, even though the malicious actor shown in red at the bottom is having a shorter path coming in, it's showing that their routing information is invalid and not to be trusted. So automatically, if your routing system, your autonomous system, is using Route Origin Validation, or ROV, the validation is happening, pulling in the ROAs, and validating the correct information. So in this case here, you would only be listening to the blue side up top, which has a valid route, and would automatically be ignoring the invalid one below, even if it's more specific and even if it has a shorter number of hops. Now, one thing to understand with Rpki and ROAs and ROVs is that this depends on more people creating the ROAs. Even if you don't do validation of your routing of your route structure back to the validator. If you create an ROA for your network, it allows other people to validate your network ownership. So creating an ROA is the first step, and then turning on validation, or ROV, is a second step from there. And those two steps can be done separately. So this is why there's such a large push from APNIC, the other RIRs, as well as large national network operators, for making sure that everybody is creating ROAs so that anybody who's doing validation can gain the benefits from that. And that's my introduction on my bit from here.
Thank you, Jamie. That's very helpful.
All right.
All right, let's talk very quickly about who should care. From both Adil and Jamie, your presentations, it's quite clear that the typical end user wouldn't see a lot of this work that's going on. But on the other hand, as a service provider, if I'm an ISP, if I'm a network operator, it's extremely important because you want to make sure that all these security features are in place. So besides ISPs and network operators, from your perspective, who else needs to care, and what other aspects do they need to be mindful of? Jamie, maybe you can go first and we go to Adil, because you're fresh off the mic.
No worries. Well, it's sort of a hygiene question here. If you're looking for end network operators, you may not be a large internet service provider yourself. If your internet service provider is not validating routes, is not doing good routing security, then it can mean that the sources that you're going to, whether it's going to search engines or going to corporate websites, those addresses could be hijacked, and you could unknowingly be redirected off to a fake website. BGP hijacking has happened accidentally in the past. I think I remember Google and YouTube addresses being accidentally hijacked and taken off into other countries where it was not accessible. But there were also malicious cases where somebody used BGP hijacking in order to take over a server for cryptocurrency, and they actually were able to steal credentials and basically empty people's cryptocurrency wallets from there. So from an end user or an end network's perspective, you want to make sure that your upstream internet provider and their connected providers are publishing an ROA and performing route origin validation so that your traffic doesn't get hijacked when you're trying to access other sites on the internet.
Thank you. And Adil, on DNS security, who else should care?
Yeah, definitely. I mean, the primary stakeholder that should care are operators, as you mentioned, because they want to provide a service to their customers that they can trust, and the trust comes from those tools like DNSSEC that ensure or provide the end user that the mapping that they have requested for and that they receive is accurate, and they can now, at their ease, access and consume the information they have online. But beyond those actors, which are the direct involved, I think we within the community, we also have a collective responsibility as organization, meaning ICANN, the area, and other organizations that are playing important role in those different, for instance, for the domain name, those different layers I talk about in my presentation, have to care. Because there is a huge need for outreach and capacity building to help people to understand the importance of those things. Yesterday, Jeff Houston was saying and explaining that there is no economy behind the DNS. For instance, we don't pay for the DNS. So if we don't pay for it, there is no business reason, there is no business incentive, for instance, for the operators to do that. But more and more we raise awareness and we get end users as well aware that they have to demand, information that are accurate. They can put pressure, and you can create a need there that can help. So raising awareness, being able, we from the technical community as well, to talk the language that everyone can understand will also help to get this together. But I think we also need to get policymakers aware. Why? Not to regulate or not to impose policy, but to also be part of this movement, this initiative of letting people understand that those things are important, and the trust is something critical for the internet. Today, we want to make sure that more and more of people who are online and who are using this beautiful technology can trust it and use it as it should.
Thank you, Adil. I think this is a good segue. So our technical speakers will get the rest for a little bit as we segue over to our industry speakers, Kenny and Jack. I think there is a good question that came up, on the economics behind this and the demand from customers. So let's segue to this other portion, because Kenny and Jack, you interface with customers more directly, more like end users more directly in a way. Before we touch on, what are some of their demands related to perhaps DNSSEC, IPv6, Rpki, and so on. The broader question, what's your take on your customers' baseline expectations of cybersecurity today versus 5 years ago? Kenny, maybe you can go first.
Okay, thank you, Jarong. And I think that's very important issue because when we consider whether that kind of protocol design is from demand-driven or from supply-driven, I think that should be a very arguable topic. For example, right now, you take Taiwan as an example. Our IPv6 penetration actually was pretty high. It's reached to I think IPv6 right now is more than 50 or up to 51% penetration. That's pretty high. And consider the Rpki router penetration is reached to more than 95% penetration. Both digit actually was excellent compared to other places in the world. But when you back to DNSSEC itself, I think the penetration is less than 1%, taking TLMD as an example. So from demand-driven point of view, can I say most of the people in Taiwan or most of the subscribers in Taiwan, they have the demand for IPv6, they have demand for Rpki or router. I don't think that would be a clear answer for any of people from Taiwan or user because they're probably not aware what is Rpki or they're probably not aware what is the DNSSEC as well. So when we're talking about demand-driven, we probably need to consider the historical evolution. For example, like IPv6 actually has been developed more than 20 years. So until last 2 to 3 years, it's getting maturized and all the penetration stopped growing. Since 3 years ago, I think all the world is pretty much have more or less the same situation. If you consider the timeline, a new protocol probably take 20 years to be mature, then we can estimate how long it's going to be mature for DNSSEC, how long it's going to be mature for example, like IDN technology. It takes time to be mature. So from demand point of view, I think that's very difficult to comment where the demand comes from. But because we are internet governance entity, we are national internet registry, we have the obligation to promote the internet, for example, more advanced standards. So we try to promote internet service provider to adopt a more advanced protocol like IPv6, like Rpki. And we also doing the same effort to all domain registrar to promote the DNSSEC. But eventually the outcome will be quite opposite because compared to DNSSEC and IPv6. So we still try to figure out what's the better way to promote that kind of advanced technology. But taking one example, we discussed cybersecurity, discuss that kind of technology requirement in the cybersecurity forum, like today here. When you change to the other venue, go to the other different kind of cybersecurity venue, they probably group of people, a group of hackers, or group of software engineers. They probably focus on totally different issues. They probably focus on what's the best way to attack, what is the best software, what would be the best technology to prevent people from being attacked. That would be totally different from the technology we're talking about today. So what makes it so different compared to the same topic on cybersecurity? One is from hacker community, one is from internet community. It's quite totally different concept. Last one thing is very clear, because the people from internet community focus on how we solving the global internet issue instead of solving a specific vendor vulnerability. We don't pay attention on specific vendor. We don't pay attention on specific system vulnerability. So we try to solve its global internet issues. So from internet protocol architect point of view, these advanced protocols are critical because we need to upgrade to the advanced protocol, ensure AV digital environment is secure and well protected under the advanced protocol. That's very critical. But most of the company, basically, they have spent a lot of money and to upgrade their software, to purchase anti-intrusion technology, but they don't upgrade their protocol because they don't consider the protocol itself is vulnerable. It seems like build your technology in the cloud because everything was unprotected in the legacy internet unless you're willing to upgrade to advanced internet. That's some of my viewpoint. Thank you.
Thank you, Kenny. It's a very insightful points. I particularly like the point you made about the difference between, say, hacker community. At a cybersecurity venue, they look for specific vulnerabilities. They tend to be sexier in a way, and it's a little bit easier to see the direct correlation. If you're looking at, I want to target a specific company, a specific technology itself. But whereas in our space, it's more about how do we upgrade to more advanced protocols from a more global perspective. You don't see it now, but in the longer term, people get affected, but they don't really see it. That brings me to wonder, the whole argument about, as a provider, I'm not getting the demand from my customers. That sounds like this argument seems moot. I think this is a good segue to ask Jack, from your perspective as a provider, a service provider, just quickly, from your view, do you hear such expectations or, you feel customers don't really care at all? And how do they affect your business decisions from Chunghwa Telecom's perspective?
Okay, thanks, Jalong. And from the point of view of the industry and as a service provider, I think the key point will be the service availability. No, I'm not going to do a presentation now, so just get back to the answer from the Jalong. And I think the key point is the service availability for the users. And what we want to provide service is keep the internet traffic can be delivered to the end user. So we have to keep this internet protocol, such as BGP routing protocol, to be maintained sustainable. So there is a question from providers. What is the evidence when I use BGP and I get your reachability information such as IP address and prefix or routes? We can exchange this information between providers And what is the evidence shows that this IP address, these routes are yours when I receive it? Okay, so you may answer me that Epinic gave it to me, but where is the evidence, right? Where is the evidence? So what is the better way to associating providers with addresses? Epinic can say, give me something that I can sign, and they will have a public key and private key, right? And providers keep private key secret and send the public key to Epinic or TMNIC. And as we all know, the person who owns the matching private key owns the addresses. That's evidence, okay? So when we take Rpki in the industry, we want to know somebody is sending their prefix to the providers, and we can do validation and know it's theirs or not. And that's a key point to make sure the BGP's information exchanged by BGP is correct. Yep.
Thank you. I think this makes a good point. From the service provider's perspective, service availability is key. So as long as we're able to provide, from the provider's perspective, if we're able to provide the service, then it's only then tying back to what Kenny said, it's only a matter of time before you feel that you want to continue to upgrade to the next important technology. That sounds to me as to be the case. I think then that's a good segue, Jack. Perhaps you can share a bit of your experience from Chunghwa Telecom in terms of adopting Rpki in your presentation. So perhaps can move to your presentation, please.
Okay. So my slides. Okay. Thanks, Shalom. And hello, everyone. My name is Wang Yanjie. You can call me Jake. And on behalf of Chunghwa Telecom, HiNet, and TWNOC, I'd like to give a big shout out to ICANN, TWNIC, and Epinic that organized this great session and event. And for our experience from the industrial perspective, I'd like to share something. But let me skip for the Rpki, and we can do, because I think Jamie explained that very detailed. So let's move to here. As you can see, the global validation snapshot from 2 years ago is we have valid about 12%, and right now in February we have 27%. Is double, right? It seems more and more providers is getting confidence about the Rpki, so we are very glad to see that, because we do the ROV, route origination validation, for that to check our prefixes. So before you do everything about your security, you have to do POC or POS to get more confidence about your this new technology, such as Rpki. You build redundant cache server and do RTL session with your border router, eBGP routers. And when you receive a prefix from others, from other S numbers, you can do validation. Okay, so when you show validation session, you will have 2 sessions, and once you have one cache server failed, you can still get another ROA data from your redundant server. And after you set up this cache server, you have to do monitoring. This is very important because we all use ROA, raw data, to do validation. So when you have a wrong or malformed raw data, you will do a wrong validation. So it is very important to do that. So you have to keep monitoring that from the raw data you collect from RARs. Then you have to monitor your V4 or V6 invalid routes. Because of when you turn on some actions, such as drop invalid, the routes will be dropped for the invalid because they're all hijack routes. And I didn't show here because of the size. Okay, and RTR session is very important. So you have to, don't forget to monitor RTR session as well, because when you lose RTR session from eBGP router to your RTR validator, the raw data will disappear. So in this case, you should not take raw data to do validation because we will reject lots of routes. So until now, we can get validation results such as valid, invalid, unknown, or not found validation states when you receive a route from other providers. Then we have 3 actions we can take. The first one is to do nothing. And second is modify local preference value of BGP. But these 2 actions still leave the risks there, and hijacking is still there. So the better one is drop the invalid, the last one, drop right here. We now have only according to the NIST Rpki monitor, we have only 4K invalid routes. So just drop it because it's really a hijack event. But in this case, your users may complain about unreachable. So here's some observations. Risks are still there, except we drop the invalid routes. So you have to drop it. And the correctness of raw data is the most important part in RPKI system. So keep your raw data correct. And other things, if you lose your RTR station with your eBGP routers, please validate the route you received as a not found or unknown state. This is a fail-safe feature because when you use a wrong raw data, it will be a big problem. And you have to figure out which network or which eBGP routers you can turn on RPKI or you cannot turn on RPKI. And after you turn on the RPKI and ROV and reject the invalid, there may be lots of questions take from users. So your NOC team, network operation team, may ask you what happened about this. So you have to read or write documents for that and do training. And thanks to T-Dominic and APNIC because they do lots of webinar about RPKI. So I think it's a better way to everyone, to providers, know what is RPKI and why should we use this. Thank you.
Thank you, Jack. Jack, I have a question. Just now when Kenny mentioned, DNSSEC deployment is very, very low in Taiwan. From Zhonghua Telecom's perspective, do you guys deploy DNSSEC or validate DNSSEC?
Yes, we have. As I said, service availability is very important in Taiwan because from 5 years ago or maybe 10 years later, the service impact is not a fraud, can be a fraud from providers. So I think the main purpose of the DNSSEC is the integrity, right? So we have to know what kind of situation that our users may have or suffer from this. And we do have DNSSEC about the edu domain. So when users query about that, we will do verification for that. But because of lots amounts of .com or other domains, we still do observations for that.
Thank you. Let's move into a Q&A discussion segment here, because I think we've jumped on some very, very good, insightful points from the discussion. If I would like to invite, if there are any questions from the floor, feel free to raise your hand. I'm not sure on the ground how it can be arranged in terms of a Q&A queue, but can you trouble you to help me do a lookout? But I'll ask the first question, which I think is interesting. So, you know, the question of from an industry perspective, service availability is extremely important. And it feels to me from this discussion that when it comes to Rpki, for example, that has a direct correlation to service availability. Therefore, from an industry perspective, adopting Rpki and ROA, there is a high impetus for that. Whereas from a perspective of DNSSEC, for example, that doesn't directly affect that service availability. Even though the query, the entire query process, DNS resolution process is important, that security aspect is important, but it doesn't affect that direct service availability. Then I'm wondering, Adil, from your perspective, how can we bridge this gap, you know, where the DNSSEC itself as a technology is important, but whereas on the other hand, it doesn't affect from the industry perspective, they feel service availability is more important. It doesn't matter what my consumers are demanding per se, as long as I can provide the service. How can we bridge the gap between the two? Because there is a gap in between for us to encourage the adoption of DNSSEC. Any thoughts?
Yeah. I think if we look closely, the notion of availability is behind the DNSSEC as well, because if you are providing a resolver service to your customers, an ISP, and your resolver is not validating, and when they want to surf the internet, instead of going to their bank, they go to a phishing bank just because the DNS query has been hijacked and redirected to another information, then you have a problem of service availability. So that aspect is not maybe highlighted enough, and we know that in most of the time, operators' main argument is that the DNSSEC will add a certain level of delay and time for resolution, which will make it a little bit slower. And I think they focus more on that aspect than the service availability, because they know that by adding those layers of security, it will cost them a little bit more in terms of resources. It will also degrade the service a little bit, because it will take a little bit more time for the validation to happen. And then when you add other protocol like encryption and all, so they see that as in terms of competition, the way that they provide the service may be degraded. But in terms of accuracy, in terms of authentication of what they are serving, I think there is a problem of reputation there as well, because nobody, or no ISP, no operators want to be the one, providing an information to access the infrastructure that is not accurate. So that problem is still there. But in general, as you mentioned, Jaron, customers don't ask those things. It's not what they want. They want to go to the internet. They want to buy stuff. They want to watch Netflix. They want to chat. That's what they care about, right? And so the outreach is more toward the common or shared responsibility of the operators there, because user delegates that responsibility to them. They trust them. Give me what I need to consume, to use this internet. How do you do that? By ensuring that you are preserving your reputation as an accurate, reliable, and secure operator is one. How do you do that? By not putting the whole infrastructure, which is interconnected, in jeopardy. Because if you are weak, you are injecting a weakness into the whole system. I think that approach can help operators to think a little bit more further into how they play with those standards in general.
Yeah, I think that's very insightful. And I like the point on the shared responsibility bit, and I want to discuss this a little bit further in a bit. Because earlier, Kenny made the comment also about, an obligation, like for TWNIC as an internet governance entity. They feel they have an obligation to promote advanced standards. And I think that's a very good point. Let's hold on to that, park that aside for a bit, because I want to ask you a bit of a larger question. You talked about the larger shared responsibility. Then you don't want to be seen as injecting into the system vulnerability into the larger ecosystem. Can you share a bit more about some broader DNS security initiatives that ICANN is pushing? For example, like DAR. Talk a bit about that since we have a bit of time, and how it ties back to shared responsibility.
Okay, thank you.
Yeah, sure. Definitely, as you all know, ICANN does not run, a big farm of DNS and provide everybody the right protocol, the right security thing. But what we do mostly is one, we do a lot of outreach and capacity building globally. But on top of that, we are more and more investing resources in monitoring and being able to provide the community, the operators, information that can help them identify where the gaps are, identify where the issues are coming from. So we have different initiatives that are already operating, like DAR, which is very specific to domain abuse monitoring, and provide monthly reports on TLDs, both the GTLD and CCTLD, that anybody can access. They are published on ICANN website. We have the DNS ticker initiative, which is a little more narrow than DAR, because it takes specific event or word and analyze them against how they are used in the abuse ecosystem in general. We start that with the COVID, where we try to analyze domain name, how the COVID situation impact domain name registration in terms of abuse, and provide a report on that, which is an initiative that will probably be extended to other key events, other world, etc. We have another initiative that is starting now, which is the Kindness Initiative, and that ties very well into the discussion we are having here, because there is one thing to talk about those evolution of the DNS, those new standards that help tightening the security around that, but there are so much moving elements that not everyone can follow them. Not every ISP has the resources to be everywhere to read all the 2,000 and something pages of RFC that define how the DNS work, etc. And we see more and more a gap being built between big ISP or operators that can dedicate a lot of resources, and smaller ones that don't have time. They don't have enough resources. And Kindness is trying to streamline what we can consider as the key best practices for operating a secure DNS. Streamlining this into not more than 10 key elements that anyone, from a small to a big operators, can just implement straightforward to be able to run the key baseline element for DNS security. We are working to develop those elements and promote them through this initiative to operators in various regions, so we can level up the best practice adoption and make sure that everyone at least can do these things without impacting the bottom line, without necessarily needing a big investment. In addition to kindness, we have ITHI, which is another measurement initiative, which we use to measure some, I would say, key indicator that let us know if the situation is evolving. For the NSX, for instance, being able to measure how many resolver are validating, for instance, and see how the situation evolve based on our outreach, based on different situation, how many sign, etc. So we have a set of initiative like that and program like that help educate, inform the community in terms of their decision making, but also allow ICANN to see where the trends are going, what is happening, and what can we do to react or help the community to react in those areas.
Thank you, Adil. I like the kindness initiative. I think it's spelled as KINDNS, but we will pronounce it as kindness.
Yes.
Yeah, but let's find out.
So it's for knowledge instantiation norm for DNS secure norm. Yeah.
Well, let's find an opportunity to share more in detail so that others can follow. I think this is a good way of talking about it. Kenny, just quick shift over to you. I'm just wondering whether on the floor at the venue, are there any questions?
Okay, I will take longer. Anyway, as Jack just mentioned, actually, when we try to, as TTM try to promote new technology, actually we spend a lot of resource in the capacity building. For example, like for example, like IPv6, we almost running a training course for every quarter, running the IPv6 training at least. And for the initial stage for Rpki training, actually we run every 2 months, very intensive course for not just a lecture, but also on-site hands-on course to all the service provider in Taiwan in order to reach the better outcome. And talking about the outcome, some of the outcome actually was tremendous. For example, like IPv6, for example, like Rpki, but some of the outcome was quite unexpected. For example, like DNSSEC. Eventually, we just try to realize, because all the technology resource originally from IETF, when IETF tried to define the new technology, basically the new technology is a kind of disruption. They disrupt the legacy business model. They disrupt the legacy technology. But something IETF didn't consider about is IETF is a technology organization. They don't taking care of any kind of user experience. And some of user experience can be managed by software automation. But a lot of user experience cannot be improved without additional protocol support. So for example, like when initial stage for IPv6, actually the very, very low adoption rate because there is no transition technology from v4 to v6. They are totally incompatible to each other. So eventually IETF realized that situation. They gradually developed different kind of transitional technology. That's why we make the IPv6 happen today. But for DNSSEC, actually, I believe we still require a lot of additional supporting protocol to enhance the transition from legacy DNS to DNSSEC as well. And that's some point. Actually, we have people queue on the floor. Do you open the floor?
Yes, please. And great points, Kenny. Thank you.
And say your name, your affiliation, and quick question. Okay, finish.
This is Guo Wei, just retired. And actually, this issue we're talking about yesterday already. I have a couple of suggestions, particularly for the ICANN pushing the DNSX to implementations. I think the first of all, I think that Kenny just explained that. The IR or even the TWNIC, they do a lot about Rpki training. You know, so often you can see that almost every 2 months or whatever, and head on to do the Rpki implementation. if you look at the DNSSEC training, actually it's not that much. And at the same time, it's not a hand-on experience to tell the people how to implement the DNSSEC. And the second of all, actually, I said that yesterday to Adele, is hopefully actually ICANN should be published some kind of the DNSSEC implementation statistics, just as IR always publish the Rpki implementation statistics, so you know where you are and where you go. And I think that's the second point. And the other thing is, I think the ICANN or the DNSSEC implementation team also help to tell the user or the community what is the DNSSEC will help for the internet security. Because currently the DNSSEC, if you are talking about in the marketing or in the promotion, not many people really understand how the DNSSEC implementation really help about the internet security or the trustworthy environments, our ecosystem. I think that is another one. I think we have to do. So that is the second point. And the last one actually is. If we look at the Rpki implementation, is going through the IR, and the IR goes through their ISP or their memberships. But how the DNSSEC is really go into the implementation or the propagation or the promotion? I think at least the ICANN can do is go first of all is go to all the GTOD as all the GTOD registry and registrar. They have to, have a report how they implement the DNSSEC, because as we know, no matter the GTOD or CCTOD, actually ICANN should have some kind of like a linkage or relationship with them. So at least you can try to persuade those of the GTOD and the CCTOD operator registry to implement the DNSSEC, and if they don't buy it, then not going to expect the other people will buy it, So you have to persuade, and those of the GTOD and the CCTOD registry, they really agree that DNSSEC is help, and they're willing to implement it. Once the registry willing to implement that, the next step is the ICANN registrar. You will have more than 3,000 of the registrar in the ICANN community. So you should begin to educate those of the registrar why they need to implement the DNSSEC, and of course including ISP and step by step. So I think that's my suggestion for ICANN to promote the DNSSEC, or from the beginning to now, we don't have a statistic. We don't have if I'm the DNS operator, I don't know what is a DNSSEC help me, particularly in the internet security issues. So I think there's something I can suggest.
Thanks, Corey. I think those are great suggestions. And those are comments. Idea, maybe a quick response on any points? Just a quick one.
Yes. Some good news, in fact, for Huawei on some of the suggestions he's making, and I think that will definitely help, and they are on point. On the stat side, as I mentioned yesterday, we have an initiative as well that is on the bill that we are calling DNS demographic and the DNS dashboard that is coming up and going to solve that statistic problem in many ways. On the training side as well, the good news is we now have extended our technical engagement team to a more stronger regional team. And I can tell you that over the past 12 months, we have more than multiply our technical training engagement by 4, moving from around 24 per year to more than 120 training on DNSSEC mainly and DNS security. So it's coming. ICANN has limited resources, so we are trying gradually to address those weaknesses. On the TLD and DNSSEC, the good news though is that most of the GTLD have signed their zone, and the problem of the DNSSEC actually is not at the TLD level. Right now, on the GTLD level, the problem is not there, but at the SLD level, or second level, signing the zone there, and where the registrar may be part of this, because most of the time, people who buy domain, they will delegate the management of their zone to either the registrar or a third-party DNS operator. And now the problem is, how do we make the automation and the signing at that second level more easy, so that anyone can, register a domain and also buy the signing there, so we can increase the number of signing at the second level. The big work, though, I must agree, still remain at the CCTLD level. We still have a lot of CCTLD who have not signed their TLD, and our awareness and outreach and training campaign target mostly those CCTLD, especially from developing country, and helping them to do this. And we are bringing software vendor into this as well, because more and more DNS software will automate the management of DNSSEC, of key management, of key rollover, of even validation. More easier it will be for smaller ISP, smaller operator to sign their zone, to validate, etc. So we're trying to bring those on board as well, so that this can be a share work and tackle those gap that you have highlighted. Thank you very much for those suggestions.
Excellent. We have a queue still, right? Let's keep going. We have 8 minutes, I think.
Actually, we don't have queue on site. I believe I have a message from Yonel. Can you check the email? Check the message in the chat box.
The chat box. There is someone who wants to ask a question. Yes, please. The organizer is typing it for me so that we can see. Or maybe the organizer can read the question directly. I think it's faster. Can we have somebody read the question? Thank you.
Or either Yonel, you can speak by yourself.
Yeah, that helps too.
Hi, this is Yoshiro. Nice to see you again. So I have 2 comments regarding...
Please louder.
Okay. Can you hear me?
Louder.
Can you hear me?
Louder.
Yeah.
Okay, good.
Can you hear me?
Yes.
Okay. So I have a question or comment to Jaro's question and Kenny's question. One comment for Jaro is content can be protected by TLS, which can be operated by contents order. And name resolution integrity can be protected by DNSSEC, which can be operated by domain owner. And as well, routing can be protected by Rpki, which can be ISP that contents order or domain owner. So that this can be said that security is layered approach, and each layer protects their own service. So security is not a single perfect solution, but it is layered, and each service or resource owners protect their own things. And using whole of their possible security mechanisms or security methods is very important to protect their services as a whole. This is comment to the Gerald. And the next comment is to Kenny. So the DNSSEC automation protocol is already developed at IETF, such as CDS or CDNS key scan and multi-signer model. But it is still underway to deploy in the registry, registrar, and registrant business logic. So I think it's very difficult to build in technology into the business logic. So that the automation is already has a technology, but the business logic is still under investigating how to deploy the technology into the business. And there are a series of DNSSEC automation panel at ICANN DNSSEC and security workshop. It will give you some insights regarding to the DNSSEC automation. Thank you.
Okay, thank you. Very helpful.
All right, we have 4 minutes. Kenny, is there anyone still on the queue on the floor?
No, there's no one on the floor.
Okay, so let's take the 4 minutes. Maybe can I invite the speakers, either share one big takeaway, or if you have one key message you want to share with the audience, what would it be? Maybe we can go in the order of earlier. So Adil, then Jamie, then Kenny, then Jack. One key takeaway or one key message.
Yeah, I will put this in terms of message and reinforce the fact that the securing the DNS and ensuring that those new technologies that secure the key critical internet infrastructure are something that we are all involved in. We are all in it, in fact. It is not one organization, one ISP, or somebody that will decide or do it for us, but we all hold a little bit of the trust that people have in the internet. The way we use that trust credit is important, and that means, implementing the right thing, the best practices that can secure that beautiful tool that we have as the internet.
Thank you. Jamie?
Yes, thank you. I think I'll actually continue on from that comment from the floor about layers of defense. And, we are talking about different layers. The person from the floor mentioned about TLS for websites, and then DNS below that, and Rpki. The important thing to understand, though, is that if you don't have every layer of security done perfect, then the layer below it can undermine its security. So for example, with TLS security, you can undermine that by hijacking DNS. If you can take over DNS records and take over a name server, you can actually issue false TLS certificates for above it. And similarly, below that, you have Rpki at the IP address level and with BGP. If you don't have the ones above done well, then Rpki and BGP hijacking that would result from it could undermine any security for DNS and any security for TLS above it. So don't rely upon just one layer, because if you don't have it done perfectly, you have to have other layers of protection in as well. And I'll take a small liberty of putting in one other small point. We're talking about important technologies, and some newer technologies. Don't ignore the basics as well. If your routers are vulnerable to other security issues, it doesn't matter if you have Rpki enabled. If your DNS servers are not perfectly patched and up to date and secure from basic vulnerabilities, then DNSSEC won't save you as well, and TLS won't save you if your web servers aren't patched. So while we do talk about new technologies that are very important and add layers of security, don't forget about the basics as well.
Excellent points, Jamie. Kenny.
Okay, thank you. I try to echo Jamie's point. Actually, security is the layer issues. You not only consider one layer. For example, like we have application layer, we have TCP IP layer, we have even bottom layer, infrastructure layer. And most of the companies that spend so much money on the application layer, if you consider security so important, so critical to your company business, then you are not only upgrade your software, you are not only upgrade your hardware. You have to upgrade your protocol to a modern protocol to strengthen your basic fundamental infrastructure, then everything will be in place. Thank you.
Thank you. And Jack.
Okay, from the perspective from the service provider, we do, of course, user experience for the internet and on-demand is the most important thing for us. So we do agree with the importance of the data integrity, such as DNSSEC is designed for that. But I have to mention that Rpki and the DNSSEC certificates has a little feel different from that, because for the DNSSEC, when you have a fail certificate or keys, you will get a server fail answer. But for the Rpki, if we get an invalid route, we can choose if we use it or not. So the service can still be available. So that's I think that's a key issue for us to take Rpki, protect our routing protocol, BGP first, and we still discuss lots about the DNSSEC, and that's a reason why we start for the EDU domain for that. Thank you.
That's a helpful point, coming back to address a point we were discussing earlier. All right, we're 1 minute past overtime. I think this has been a very good and robust discussion. My key takeaway is a shared responsibility. Demand from customers is important, but on the other hand, as the internet governance community, all the layers have to come into play, and we have to think about, as a community, how can we further raise awareness and work together to have that shared obligation to ensure security continues to provide and keep the internet going. So that's my takeaway. And that's with that, we'll wrap this session. Thank you so much. Thanks to the panelists and thanks to participants. Thank you all for taking the time.
Thank you. Thank you very much, Mr. Law, for moderating the session. And thank you to all panelists for this very animated discussion.